Okay, let us do a quick recap about the previous session. We have seen some queries on equi joins to retrieve employees who are working in London location. Now, yeah, we have seen that, and also we have combined these equi joins with grouping by and aggregate functions, right? So we have we have prepared some queries for that, right? What else we have seen? Okay, we have started about outer joins. The outer joins are right, it will retrieve, it is powerful enough to retrieve both matching data as well as the unmatching data from multiple tables. So equi joins means it will retrieve only matching data. Outer joins means it is going to retrieve both matching as well as unmatching data. So you have something like left outer join, right outer join, and full outer join, right? So the left outer join, and again we have discussed this in both ANSI, non-ANSI and the ANSI formats, right? So it retrieves matching data from both the tables, but unmatching data from the left side of the table. Right outer join means right side of the table, and full outer join means you will get matching and unmatching data in both the tables. Right? So this is all about our previous session. So today I'm going to introduce about the non-equi joins. What is it? Non-equi joins. Non-equi. So what is this non-equi joins? Okay. So equi means, remember this keyword. Equi means when you say equi joins, it means you will be using the equal to operator to perform the joining operation. So this is going to be acting like a joining condition. Likewise, for non-equi join, when you say something as the non-equi join, you will be using what? You will be using the operators which is not equal to, right? You can use operators like greater than operator, lesser than operator, and greater than or equal to. You have lesser than or equal to. You have not equal to, right? And you have the and. You have the between. So these are the, apart from equal to operator, you can use the remaining operators that we have in the Oracle SQL. That's why it is called as what? Non-equi joins. So simply I can say that retrieving data from it is used to retrieve data from multiple tables. Retrieve data from multiple tables based on any condition except equal to, except and equal to operator condition. Okay, so in this operator you will be using what? You will be using all these operators. Not equi join can represent all these operators except the equal to operator. You can represent all these operators. Okay, this is specialty about non-equi joins. So you'll understand this with one example. I just want to create my table. A connection has been established with the database. So let us establish the connection with the database. MyDB 7am, MyDB 7am. The connection has been established. I want to create two test tables. Let me create tables quickly. Create a table. The name of the first table is test1, right? And I am going to take the serial number as the column name. Is of what? Integer data type. The second one is I want to take something like the name. Column name is name itself. Is of varchar to data type, and it is going to accept 10 characters. Okay. Table 1 is created, and I want to insert values. Insert into test1 values are supposed to be like 10 comma let me say something like Suresh 20 comma Ramesh. Okay. So this is the table 1 data, and I also want to create another table. The name of this table is test2. Test2. So in the test2 table, I'm going to have the serial number as integer, and I will be having the salary here. Salary, the column name is salary, which is going to be of number type. Okay, let me insert values. Insert into test2. Okay, the values are like 10 comma salary, right? Salary, let us say 10,000. 30, let me say 15,000. Okay, two tables. Let us see these two tables. Select star from test1. So this is the table 1 and this is the table 2. Now I want to perform non-equi joins on these two tables. I have two tables, I want to perform non-equi joins. So look at this. Look at the simple example. What I'm doing, I'm saying select star from test1. Okay, comma test2. In the non-ANSI format, I am doing this. Select star from test1 comma test2. Okay, let me give the alias name also. Test1 t1 comma test2 t2. Okay, where t1 dot serial number is greater than t2 dot serial number, right? Okay, this is t1 now. Yeah. See, in the equi joins, we always use the equal to operator as as the joining condition. Okay, so that is going to be represented in the equi join. In the non-equi join, apart from equal to operator, you are eligible to use the remaining operators. So even you can fetch some kind of results by using this greater than operator. So how the results are going to come? If I execute this code, you are getting the value. You are getting it's able to join two rows from two different tables based upon this condition. So what is happening behind the scenes? So this is the query that I have taken. Let me copy these tables. Okay. So these are the tables. I have two tables, and this is the query. You just observe the query, just observe the joining condition. So I want you to observe this joining condition. So this is the joining condition. So T1 dot S1, right? SNO. We are dealing with the SNO column name, SNO and SNO, right? So I have the information like in the test1 serial number, I have 10 and I have 20, right? Likewise, in the test2 serial number, SNO, I have 10, I have 30, right? So first these two will be compared logically based upon the greater than operator, right? So it will be comparing if 10 is greater than 10, obviously it is false. So this row will not be joined, right? Next, this is going to compare the second value. This value will be compared with the value that is in the second table. Okay, so again the 10 is greater than 30. This is found to be false. Okay. Now the second one. 20 will be compared, isn't it? 20 will be compared with the first value of the second table. If 20 is greater than 10, of course it is true, right? So these two rows will be joined. This row and this row will be joined. 20, 10 is going to get joined. If you see the result, okay, serial number 20 and the relevant row, the serial number 10 and the relevant row between two different tables have joined based upon the greater than operator, right? And if you see the next one, next comparison, 20 and 30, right? 20 is greater than 30, it is going to be false. 30 is going to be. So that's why the output is what? Output is something like only one thing you are getting in the answer. Only one thing. If I do the opposite thing, okay, if I just do the opposite thing, instead of using greater than, I use lesser than, okay, based upon the condition, the respective rows between two tables will be joined. Okay, now these conditions are satisfied. 10 is lesser than 30, satisfied. 20 is lesser than 30, satisfied. That's why these two rows are joined. This is an idea about what? This is an idea about the non-equi joins, but there are a lot of operations that you can perform by using non-equi joins. You'll understand this better with another query. Okay, let me present you that query. The next query would be like this. Now the query is, write a query to display employees whose salary is between low salary and high salary from employee table, from employee salary table. Okay, there are two tables, guys. Okay, there are two tables. So you have given the employee table. You are able to see the employee table, as well as you are able to see a table by the name of salary grade, sal grade table, right? So what they are asking you to find, you want to fetch each and every employee, and also you want to fetch if their salary is falling between the low salary and the high salary of any grade in the salary grade table. But let me show you the salary grade table. If you remember or not, in the beginning, at the time of the table creation, employee table creation, okay, we have created a table like the sal grade table. Okay, let me set the page size to 100, set lines to 50. Select star from M. You have the employee table. Select the star from sal grade. Okay, so this table has been created in the beginning of our class. Okay, so just remember there is a sal grade table, and you get the grade column, and you get the low salary column, you get the high salary column. If any employee is falling, for example, John, okay, John's salary is like around 10,000, isn't it? 10,000, right? So he might not be falling in any of these grades, right? So let us take another person's. Okay, let us take the Mike's salary. Mike's salary is 65,000, right? So Mike's salary, Mike would be part of, the this one, second grade, right? Likewise, let us take something like Ami's salary is 72,000. 72,000 is part of which grade? 72,000 is part of the third grade according to the salary grade table. Okay, and if you find any employee and you want to display their grades, on which grade they are falling. Okay, so the query would be like this, guys. So here, so the idea of drafting this query, idea of preparing this query is to understand about the non-equi joins. So what are the expectations? If you go back to the query and see, right? To display employees, we want to display the employees whose salary is falling between low grade and high grade. So they are expecting what? They are expecting employee employee name. Okay, they're also expecting the salary. Okay, and we also need to display the grades of the salary. We also want to display what the grades of the salary. D sal, okay, low sal, as well as what, as well as the high sal. Okay, so these four columns are expected from which table? From employee table, and the salary grade table. Salary grade table. Okay, these columns are expected. So I want to use a select query to select all these columns, right? I want to use a join query to join which table? To join employee table as well as the salary grade table. Right? Since we are talking about the non-equi joins, the joining key is going to be the join itself. Joining key is going to be what? The joining key is going to be join itself. Right? And we need to talk about the condition. Okay, what is a condition? Choose the salary in each and every employee table. Choose the salary in the employee table, salary column in the employee table, and we need to check. We need to use the between operator. Between operator, okay, whether this salary is falling between, okay, low sal and high sal. That's it. Okay, this is the condition. This is the joining condition. I have just said for the non-equi joins, you are not going to use the joining condition like the equal to operator. Instead of using equal to operator, I am using the between operator. Okay, so this salary is part of what? This salary is part of employee table. This column is part of employee table, and this low salary and this high salary is part of what? They are part of sal grade table. This is part of employee table. So it will fetch any salary. First, it will fetch any salary from the employee. Okay, from top to bottom. Let us say that the employee salary is 1,000. Okay, this 1,000 has to get compared. Okay, between these two conditions, low salary and high salary. Let us say that if the low salary is something like 5,000. Okay, and let us say that if high salary is something like 20,000. Right? So 1,000. Firstly, 1,000 is will be checked by using between operator. Okay, it will check. Okay, if this 1,000 is falling between these two conditions, is fitting in these two conditions, right? So it is going to be true. Then, okay, the respective rows between two tables will be joined. Right? Let us understand this by select star from. No. We want to select what? We want to select employee name, salary column. Okay, we want to select low salary. We want to select high salary. Okay, from employee table. Okay. Using the non-equi joins, the join key is going to be the join itself, and select the salary table. Okay, on. Okay. Every salary. I'm taking the salary column. Okay, I'm taking the salary column. Every salary will be compared by using what? By using which operator? Between. Whether it will be between low salary as well as the high salary. Okay, 10,000 will be compared with the low salary and the high salary. Combination of low salary and the high salary. So you are trying to find whether by using the between operator, whether the salary value is fitting in between these two values. If it is fitting in this between two values, then condition will be true. Those two tables will be joined. Okay, let me enter this. 95,000. Okay, the value is fitting between these two, falling in between these two. Right? Again, Emily is also 95,000. It is falling in this between two. Dan is 87,000 is falling in this between two, right? 76,000 is falling in between two. See, only 9 rows are selected, right? And if you see totally there are 10 rows in this employee column, because 10,000 is not falling between any component of low salary and high salary column. This salary table, right? This is the query. This is one of the examples where you will be using what? Where you will be using a non-equi joins, right? Example like this. So by looking at this, you can also draft another query. I mean, the same similar query, okay, without using between operator. Without using between operator, you can draft a similar query. The query would look like this, okay. Instead of using the between operator, you can simply use. You can remove this. You can simply use if the salary is lesser than or equal to low sal. Okay, low sal. The salary is lesser than or equal to low sal, and if the salary is greater than or equal to high sal. Okay, so if you want to avoid using between operator, and this is the other way that you can use, and the result is going to be same. The resultant value is going to be same. This is also valid. Only I'm changing the operator. Instead of using between operator, so I am directly using the the logical operators, comparison operators, greater than or equal to and lesser than or equal to. Every salary will be checked with the low salary and the high salary. If that is fitting, those two rows will be what? Those two rows will be joined. Let us see if it is working or not. On salary is lesser than or equal to the low salary. Salary is greater than or equal to high salary. Fitting. Both are giving the same result. So this is all about the non-equi joins, right? The next one is we will understand about the another join which is asked very frequently in the interview questions, the cross join. So by looking at this cross join, you might be thinking that it is a kind of useless join because the way it works will not satisfy our requirements. So that is how our thoughts are. Cross join. So what is a cross join? Okay, so the cross sign is like it is going to whether the condition is true or not, whether the condition is true or not. For example, if I have two tables, guys, if I have two tables, okay, this is table 1 and this is table 2. No matter if the condition is true or no matter if the condition is false. Okay, this is two table, and in my two table, I have two columns. Okay, two columns, and I have what? I have two rows. I have three columns and I have two rows, right? So this is, let us say that it is table 1 T1 and this is T2. Cross join, what cross join says, right? Other like if you see equi and non-equi joins, they go by the conditional check. Only if the condition is true, okay, the rows will be joined. Okay, the rows from the multiple tables will be joined. But cross join is not like that. The condition is true or if the condition is not true, no matter, right? Every row. Okay, if you take first row, okay, let us say that this first row of the T1 and this is the second row of the T2, and this is the first row of the T2 and this is the second row of the T2. Okay, it will join, the condition is true or not, it will join 1 1, 1 2, 2 1 and 2 2. Okay, the output is going to be like 1 1, 1 2, 2 1, 2 2. Okay, if we have rows, like for example, if we have let's assume that in the T1 table you have 4 rows, the T2 table you have again 4 rows, right? The output is going to be what? Output is going to be 16 rows. 4 into 4, 16 rows, because it will not depend upon any condition. It will simply join. It will simply join. Why it is going to simply join, and what are the phrases that we are going to use, that we will understand now. It will not check any. First thing is, it will not check any condition. Okay, simply means the every row from the first table is combined with every row from the second table. It is going to result in a large number of rows, no matter what the condition is. Every row from the first table will be combined with every row from the second table. Okay, the please be informed that every row in the first table will be combined with every row in the second table when you use cross join. Okay, cross join will not follow any condition, not take any condition while joining rows from multiple tables. Second thing, right? For example, you can imagine like this. For example, let us say that like a table has m number of rows, and another table has n number of rows. Okay, the resultant rows be m into n, m cross n, m cross n rows. Right? So, like I said, it does not require any joining. First thing you have to take care is, it does not require any joining condition. Typically, it is used in areas like where you need to generate the large test data, right? Where you want to find the all possible combinations. Okay, use cases are like For example, okay, in your company, if you want to generate some test data by using two tables, right, you have to find all the possible combinations, the use cases. Okay, to generate test data. First thing is to generate test data. Like when you need to create the combination of to get a combination of all possible languages. Create a combination of all possible values. The first thing, okay, and the second thing is, right, you can use this for the simulations, for the statistical calculations, right. The third thing is, especially see somewhere sometimes in the areas like when you visit the supermarket, they produce the bill. Okay, bills will be generated, right. So in the bills generation, not the bill generation, just imagine that you are visiting the KFC, right. The KFC, always you see the combos, okay, combos pack. You purchase two different items, right, and the prices will be calculated for these two different items by using this cross joins only. And you can purchase, okay, let us say that there are two tables. Let us say there are two tables. One table is meant for the KFC snacks, and the second table is meant for the KFC drinks. Okay, you have two KFC snacks, okay, and you have two KFC drinks like Pepsi and Coca-Cola. KFC snacks are like, okay, you can take burger or pizza, whatever it is. Okay, assume that there are burger and pizza. You have burger, okay, and you have pizza. Pizza, and you have drinks like Pepsi, and you have drinks like Coca-Cola, whatever it is, right? So you are asked to purchase, one item from this table. I mean, from this snacks, and one item from these drinks, snacks and drinks, right? So these bills will be generated. The total price will be generated according to this cross checks. We'll see how it can be generated with the with the small example. I want to see how it can be generated with a small example. Let me show a complete picture by using the course table. Okay, let us say select start from course. We have a course table, okay, and we have what? We have something like students table. So these tables were created the previous sections, right? In the course table, you have four rows, right? You have one row, second row, third row, and fourth row. The student tables, again, you have four rows. The moment you starting, you start using the cross join. Okay, when I say select start from students, cross join. The joining key is cross join. Cross join course where, okay, you have to place the condition. Okay, where usually in the equi joins and the non-equi joins, the condition is mandatory. But this cross join is like, this cross join is like, it will not depend upon any condition. Simply it will join. Okay, this oracle will be joined. This row will be joined with these four rows. Okay, this row will be joined with this next four rows. This row will be joined with the next four rows. Okay, if you look at the number of combinations, there will be 16. How you are getting 16? 4 rows into 4 rows. 4 into 4 is equal to what? 16. You do not need to have any where condition here. It's simply it is going to join. Okay, the Ganesh, okay, Oracle, Ganesh again Java, Ganesh again .NET, Ganesh again. Okay, this example is not making any sense, right? This example is not making any sense. Why this happening? Now I will give you another example where you will get some clarity. Okay, the example is like, I want to create, to understand this example, I want to create a table like create table item 1. Okay, item 1, the column name is what? First column name is serial number, which is of integer type. The second column name is item name, which is of what? Varchar 2 type, which is accepting 10 characters. Okay, and I'm taking a column like price column, which is of number data type. Okay, 1 minute. Name is already existing. Okay, let me delete this. Drop table item 1. Drop table item 1. Purge. Table drop. Okay, the table has been created successfully. Okay, so I want to insert values. Insert into item 1. Values are like the first one is what serial number 1 comma item name is, let me take burger. Okay, and the price of the burger is, let me take something like 150. Okay, another table, I mean another row, I am adding another row. Serial number is 2. Instead of burger, I am saying it as pizza. Second item is pizza and price is something around 300. Okay, select. Select select a star from item 1. Okay, these are the items that you have. I want to take another table. Create table item 2. This time I am taking the second table as item 2. Okay. Serial number. Okay, I am taking the serial number as integer, and I am taking what item name as item name itself, barker 2, right? And last I can taking the price number as price number itself. Okay. Same thing I am taking. Item 2 is also there. Deleting that, I'm creating it one table. So item 2 table is created. Now we will insert values. Insert into item 2. Okay. 3. Instead of pizza, I'm taking it as Pepsi. Pepsi value, I mean price is 25. Okay, and item 4, let me take as Coca-Cola, value is 30. Okay, 2 tables are created. Select a star from item 1 and select star from item 2. So you have the, in the item 1 you have burger and pizza, and the item 2 you have the drinks. You can say that snacks table and the drinks table, whatever it is. Okay. Customer comes, customer has asked to purchase one thing from here and one thing from here, right? First of all, you need to generate all the combinations. Okay, you may be at any point of time you may be selecting any two things, one thing from this table and one item from this table. You need to find the total cost at any point of time. You need to generate what? You need to generate all the possible combinations. How you can generate all the possible combinations? By using the cross join. Right? Firstly, in this case, you need to select what? Right? You need to select I name. Okay, item name. Okay, and you need to select what? But in this example, there is a confusion. Okay, you want to select I name, but this I name is part of both the tables, and you want to select the price, but this price is part of both the tables. What I can introduce? Okay, I can do something like this. Okay. From, okay, I can create alias names. Okay, for the item 1, I'm taking the alias name as I1. For item 1, I'm taking alias name as I1 and using cross join. For the item 2, I'm taking alias name as I2. I'm able to I'm able to do the cross join by taking the alias name. Okay, from item 1 and item 2, in between there is a join key, which is what cross join. These are the aliases I1, I2. Okay, by using these aliases, I can call what? I can call the respective tables. What I can say, first select I1, alias name is I1 from what? I name. Okay, Second one is I1 from what? Item 1 price, comma, I2 dot INAME. Okay, I2 is what? Alias for item 2 table, comma, I2 dot price. Okay, now it is very clear. Okay, I am selecting 4 columns. I'm selecting, 4 columns. Okay, column, this column, this column, this columns from item 1 table and item 2 table. I have used the join key as cross join. So in the cross join, no condition is required, like where condition, things like that. It is not even required. So just enter this. Okay, you are getting the resultant value as this. Right? Let us say that customer is selecting this combination. Right? So he has price 150 and he has price 30. He has to pay 180. I also want to display the column which is generating the total bill. Okay, so if you take this row as an example, you have the price tag as 150 for burger, you have the price tag as 25 for the Pepsi. I have to display a column where it is going to show 175 as the total price for these two combinations. How I can do that? Simply by taking what by taking another column. Okay, here I am taking another column as I1 dot price. Okay, plus I'm doing the an arithmetic operation I2 dot price. Okay, this resultant value should be displayed in the part of what I'm taking an alias name like total price. So a column will be created. That column is going to have the values of what? Summation of two prices from item 1 column and item 2 price column, right? So 150, 25, 150, 30. Every value will be having this arithmetic operation, and the resultant is going to be what? The resultant set is going to be like this. Okay, now you get what? 150, 25, 175, 150, 30. All the combinations you are getting. 30, 25, 325, 330, 330. The customer is selecting, this combination, you have the total price. Customer is selecting this combination, you have the total price. Making sense? So this is where, okay, these are the areas where you will be using the cross joins. Okay, in the interview room, if they're asking you questions, cross join do not have any condition. First thing, right? Okay, it is going to fetch all the possible combinations. Second thing, so this is where, okay, these are the examples where you can use this cross join, right? Okay, next one is what? Next one is we have natural join. These natural joins are very easy. If you understand equi joins, you have already understood these natural joins. Natural joins. Okay, it is similar to equi joins. It is similar to equi joins. Okay, how it is similar to equi joins? Let me take an example from equi joins. Okay, I want to select. Let me clear this. I want to select what? I want to select start from students. Yes, inner join for C. Okay, on s dot cid equal to c dot cid. Okay. So this is the typical inner join query, right? You know this is a typical inner join query. So based upon this equal to operator is going to join the rows from two different tables, right? So let me take this an example. It is similar to equijoins. So I have mentioned that it is similar to equijoins, but what is the difference that you can see? What is the difference you can see? And if you see, I can segregate this part. Okay, you have the condition here. Okay, you have what? You have the joining key. You have, okay, and you have what? You are selecting something, right? Ah. When you use natural join, okay, Implicitly Oracle software itself will take care of writing this condition. Okay, if you give any two tables for the Oracle, okay, in this case if you say you have the you are dealing with the student table, okay, select star from students, okay, select star from course, okay, two tables are there, right? Oracle itself will identify the common column names among these two tables. Now CID is a common column name. It will write this condition for you. Oracle will write this condition implicitly for you. This condition will be written by Oracle software will take care of this condition. First thing, software will take care of this condition. Okay. Will write this condition. First thing, you do not have to write this explicitly for natural joins. For natural joins, you do not have to write this condition explicitly. Right. The second thing is, if you see the star, okay, and in our example, so there is a duplicate, right? Duplicate columns are not ignored, okay, they are repeated. CID is a duplicate column, and again the CID is also a duplicate column, right? Both are duplicates. These duplicate columns will be taken care. Only unique columns will be considered by the natural joins. Even though you use star, natural joins are going to consider only unique columns. Duplicate columns are removed. Duplicate columns are removed. Secondly, right? That is why I said it is similar to equi joins, but the condition will be taken care by the software itself. The duplicate columns will be removed by the software itself. I can write it like this. Similar to equi joins, for retrieving data. Matching data from multiple tables. Based on equal to operator. Based on equal to operator. Okay. And join condition is prepared implicitly by the Oracle software itself. Join condition is prepared implicitly by Oracle software itself. Okay, but when you the equi joins, you as a developer, we are supposed to prepare what? We are supposed to prepare the joining condition. Okay, and the next important thing that you have to remember is, when you are performing the natural join, always remember to have the common names. So there should be at least the common column name between two tables. So tables must have the common column name. It is mandatory when you are whereas in equi joins there is no need to have a common column name. That is optional, right? Look at this table. In this table, you are performing natural. If you are performing natural joins on these two tables, okay. So the Oracle software will identify whether if there is any common column name between these two tables. If it is there, then it will perform what? Then it will perform the natural join. If not, it will throw an error. Okay, example we will see. Okay, first understand this theoretically. Okay, what it says. When we use natural joins, tables must have common column name is mandatory. Mandatory, whereas in equi joins, there is no need to have the same column name. It is optional. No need to have the same column name. It is optional. The first thing. Okay. And the next one is natural joins are going to avoid the duplicate columns, right? So we have discussed that. Whereas the equi joins, your it is not it is not like you can avoid the duplicate columns. Natural joins implicitly is going to avoid duplicate columns. So everything is fine. How we can use the natural joins? Okay, go back here. The query, okay, if I want to use the equi joins, how is the query supposed to be? Select star from the query is already written, right? So this is the query for the equi joins. Then for the natural joins, the query would be like same query I'm taking. Select star from students. Okay. I do not have this joining condition, not required. The joining condition will be written by the software itself. Instead of inner join, I can use what? I can use the keyword natural join. Okay. Now you see the difference between the equi join. Equi join, you are placing the condition here, right? The natural join, no such condition. Conditions are avoided. So implicitly, condition will be taken care by the software itself. The second thing is you have 6 columns here because duplicate columns are also there. But in this case, duplicate columns are avoided, eliminated. Only 5 columns are there. And also, this is happening. Okay, these things are happening because there is one common column name. One common column name is that. That's why you are able to do this. Now let me change the column name. Let us see the consequences. Okay, I want to alter the column name of. Let me say alter table course. Okay. Rename column. What is the old column for C E? I'm changing the CP column name to let us say it as piece. The table alter. If you see, select the star from students. Select star from and okay. Now there is okay. See, I have changed the piece. Okay, I'm sorry, guys. I'm supposed to change CID. Okay. Alter CID to okay. So SID, S name and CID, ID, C name and piece. So I don't think any common column names are there, and I want to perform what? I want to perform the natural join. Okay, the output is completely weird. You're not going to get what? You're not going to get the exact output that you're expecting. It's behaving completely weird. Actually, the joining itself is not happening here. Instead of doing inner join, it is considering what? It is considering each and everything. Right? So Ganesh, okay, it is joined. This row is getting joined with the row of the course. This row is getting joined with this row. This row is getting indirectly. I think you can see a kind of what you can see a kind of cross join. Performing natural join, but it's something is doing it is creating a kind of what kind of cross join. You're not able to do this actually. The behavior is going to be weird, ambiguous behavior. Right? So that's why you have to ensure to get the right behavior, you have to ensure that the column names are matching. At least one common column name should be there. Right? Let me see. Okay, let us see if it is working for the inner join. Okay, I'm saying inner join s dot cid and c dot for inner join it is working fine. Inner join we are explicitly writing the condition, so we do not have any issues. For the natural join, since the software is going to write the condition, right? Since there is no matching column, the output is going to be weird. Right? So takeaway is very simple. What is natural join? Okay, if you are lazy to write any condition, simply if you want to see the common column, okay, if you are having any common column between two tables, right, if you want to join that, internally natural join is inner join, where the condition will be written by the Oracle software and the columns, okay, columns wise, duplicate columns will not be displayed. Apart from that, everything you have to ensure that you are having at least one common column name between these two tables. Simply to see the not to see to just to see the inner joins without writing any condition. Okay, this is how you can utilize the natural join. The real-time applications, okay, just to see the data, you will be using this very often, right? But not much. Okay. The next topic, okay, next important topic is we have what self joins. This is very important topic, right? Understanding this is going to be it's not going to be easy. It is going to be a little bit confusing. I don't say difficult. It's going to be a little bit confusing in the beginning because the remaining joins what we have discussed so far, we are dealing with two different tables, more than one table, right? But for the self join, you will be dealing with the same table. Okay, you will be joining. Okay, it is going to join by itself. Okay, table is going to join by itself. In a one table, you will be dealing with two different rows, right? And you use those data to join. The self joins are going to deal with the same tables. A table itself will be joining. Okay, you're going to join the same table. You will perform the operation on the same table. Table itself is going to the table will be joining itself. Okay, we will discuss this tomorrow. Tomorrow also will try to take class because Sunday no issues. Tomorrow also will try to take class. I will inform you today because we have missed so many classes now. Tomorrow also will take class. If it not at 7 o'clock, I will take it at 8 o'clock because I am facing power cut in my village. And we will see tomorrow. I will inform you today. The classes are there.